Hello everyone, today we're continuing on learning Rust. Okay. Last time we did a second quiz. And it was, I would say, kind of hard. I mean, not hard, but I would say challenging, okay? And actually I was thinking a bit about the quiz itself. And I think this part we could make it better. So here I think we can destruct the tuple. Wait, can we really? Yeah, I think so. Yes. And then we're going to match the CMD, right? Okay. Well, let's leave it at that. Okay. So no. Okay. Yeah, I think I shouldn't like really play with refs right now. Because, you know, it should work. Okay. Let's check the solution again. Well, I don't really understand how it works for them, but they don't get the references. And if you do an iterator, I think it does references. Well, I don't really like completely understand what happens here, but we did make an improvement. And I think it's gonna teach us about references and stuff later, so we should just continue to the next exercise. Okay, so we're learning about options now. Let's see. This function returns how much ice cream there is left in the fridge. That's before 10 p.m. Then 5 scoops are left. At 10 p.m. someone eats it all, so no ice cream is left. Return none if hours of day is higher than 203. Alright. I think we should check out the readme file for this exercise. Okay, so this is the option, it's an enum, right? You can store a value, it's also a template. Okay. So we should return an option. And I think we should use if condition, so if hour of day more than 23, we return none, and else we return some. Still get an error. Why though? Don't change this line. Okay, fix this test. How do we get the value contained in the option? How do we get the value contained in the option? That's a good question. Okay. Option module documentation. So this is basically what we just did right now. There should be a way to like get some. Maybe do it like explicitly. Oh, there is a question mark operator. Okay. Will this work? I wonder. Doesn't. Well, it does return an option. Right? Does return an option? We should be like this. Oh. And then the expression with question mark will result in some wrapped value, unless the result is none, in which case none is returned early from the enclosing function. Can be used in the function the return option because of the early return of none that it provides. So actually it isn't what we need. Maybe we need like unwrap or something. And indeed fail for some reason. Why though? Well, 12 is less than 23, so it should return. It should return as 5, right? But it doesn't seem to do so, actually. Oh, okay, so oh, I get it now. I've missed the condition. It should be else if hour of day is like 10 p.m. Should return why it gives me an error. Should return some 0. Now it should work, right? Yes. Maybe we should do something like this, I guess. Just to be consistent. Also, let's check out the solution to this. Okay, so we can do a match. This is actually nice. So it's from 0 to 21. Didn't know I can do this. Does it actually... Is it actually in the Rust language book? Okay, action resource. Matching named variables. Multiple patterns. So we can use this to have like more values than one. Okay, so you can match ranges. Good to know. Let's go back to the exercise. I'm gonna write this match. So if it goes from 0 to 21, we return sum with a value of 5. Then if it goes from 22 to 23, right, we return sum with the value of 0. And by default, just return none. Should be good. Okay. Let's go to the next one. Make this an if-let statement whose value is sum. Okay. So the readme does has something about this if-let statement, and we should check this out. So we can like unpack a value, it seems, if we use this. So if it has like, if the option is sum with a value of I, the condition will run and I will become a value. Okay. In this case, optional target is sum. So we need to do this if let word equals sum. But for some reason it doesn't work. Why? Oh, because we need to do it in the reverse direction. Oh, okay. So we do like this. I get it now. Oh, okay, we have another to do. Like this is a while let statement. Remember that while pop, it's another layer of option. You can do nested pattern matching in if let and while let statements. That's gonna be interesting. So I think we should open a vector page, right? std-vec. And we need to check out the pop function. So it returns an option. And while we have options, we should continue going. But it also says something about nested pattern matching. I don't know why would we need a nested pattern matching, to be honest. But let's see. Do we have something? on while. Why am I editing this? This is weird. For some reason, it doesn't seem to be working. Okay, so I shouldn't click the code blocks. Let's search for a while. It is kind of weird today. Should be somewhere here, right? I don't see any whiles. Wow. This is awkward. Okay, well, there is another page on while let specifically. Oh, this is how it works. So, just a syntax sugar for this statement. Or so it seems. Okay. So we start with while let some integer equals to this. Oh, I get it now. So this itself returns an option. But so is this one. Can we do it like this? We can, but is this the expected solution they want from us? Yep, okay. Fix the compiler error by adding something to this match statement. So what's the error? We shouldn't change this line. Okay, so we have this value and we do some matching, and then it gives us an error which seems to indicate that this point struct was moved to this p variable, and the optional point variable isn't really valid anymore, so we need to somehow fix this. Okay, can we do just something like this? Or maybe something like this. Well, I don't know if it's the intended solution, but it did work. Let's check out this. Okay, so there are two possible solutions. You can either do what I did, or you can use a ref keyword to specify that this p variable, we're gonna take it by reference. Interesting. Okay, so now we're starting to do error handling. This function refuses to generate text to be printed on a name tag if you pass it an empty string. It would be nicer if it explained what the problem was instead of just returning none. Thankfully, Rust has a similar construct to option that can be used to express error conditions. Change the function signature and body to return a result string instead of option string. Okay, so now we're getting into the result territory. And we need to read about this. So I think we would need this one. Maybe also this one. Let's start from first one. Recoverable errors with result. Okay. So basically what happens is if a function does return a result, can be okay and contain the actual expected return value, or it can be an error and contain some kind of information on like what really happened, like what was the error. There could be different types of errors. I mean, it looks similar to like try catch. All right. Result is a richer version of the option. Okay. We shouldn't return an error, we should return a string. So first of all, we need to change this to result string, and then if we get an empty string, we return. We should return this, right? We should return error. Is this message. And we should make it like a string. Otherwise, should return okay. And this seemed to be the expected solution. Okay. There are like 6 of those, 6 exercises on error handling. Say you're writing a game where you can buy items with tokens. All items cost 5 tokens, and whatever you purchase items, there is a processing fee of 1 token. A player of the game will type in how many items they want to buy, and the total cost function will calculate the total cost of the items. Since the player typed in the quantity, we get it as a string. They might have typed anything, not just numbers. Right now, this function isn't handling the error case at all. What we want to do is, if we call the total cost function on a string that is not a number, that function will return a parse integer error. In this case, we want to immediately return that error from our function and not try to multiply and add. There are at least 2 ways to implement this that are both correct, but one is a lot shorter. Okay, so we have this total cost function and we need to implement error handling. Done. We're so smart. Just one single character. Solved. Okay, this is the... So we can do it like this. I mean, yes, this would be actually kind of more sensible. I'm gonna do it like this, but like this. Okay. But you can also do it like this. I mean, this is like just this, but more verbose, I guess. Okay. Next one. This is a program that is trying to use a completed version of the total cost function from the previous exercise. It's not working though. Why not? What should we do to fix it? So we shouldn't change the function. What we should do is change the main function. Okay. Well, I mean, it's easy, right? Just gonna return result. And gonna be like this, I guess. Maybe like this. I don't remember the correct variant. Okay, is this the proper solution? Let's see. Yes. Okay, very good. And onto the errors exercise 4. Actually, I just want to check, did we miss anything? No, we didn't. So what's next? We do finish with errors. Then we have generics, then traits, and then we get the third quiz. Actually, I think we could maybe do it today. I mean, during this session. We only have like what? Like 10 exercises? Alright, let's first do the one at hand. This function shouldn't always return an okay. Why wouldn't it always return an okay? So... kinda understand what it's trying to do. So we give it an integer, which is signed integer, but we do return a positive non-zero integer. So, I mean, the basic solution would be if this is less or equal to 0, we're gonna return an error. More specifically, creation error. Oh, there are two types of those. Okay, so I guess we do a match. Yeah. So how do you match with a... I mean, it could be arranged, but a range of what exactly? Do I have the like parent thingy open? So So this is a range, right? But can you match conditions, by the way? Okay. So if this how actually do this one? So maybe you do like x if x less than 0, right? We give it an error, more specifically creation error, more specifically it's a negative number, right? Then if it's 0, then it's well, it's creation error 0, right? And at last they seem to be working, but does it really? Can we do it like this? We can't. So we need to. Okay. Okay. So I don't know if it's the most elegant solution, but it is a solution. So let's see what they wanted us to do exactly. Okay, so you can do this, but how are we gonna learn about something like this? Well, it seems that for every primitive data type, so let's check I64. It has some methods. And what we're interested in is this. There's a CMP method. Okay. I see. Well, let's rewrite it so we remember that we can do it this way. I mean, but it's solid anyway, but it's better to learn how to do it this way. So I'm gonna do it like this. Uses an error though. Why? Because it says it's an undeclared type. So they didn't import it. Let's go to the next one. This exercise is an altered version of the errors for exercise. It uses some concept that we won't get to until later in this course, like box and the from trait. It's not important to understand them in detail right now, but you can read ahead of you. Like, for now, think of the box tune type as I want anything that does. Okay, in short, this particular use case for boxes is for when you want to own a value and you don't care, only that it's a type which implements a particular trait to do so. The box is declared as a type box dynamic trait, where trait is the trait the compiler looks for on any value used in that context. For this exercise, that context is the potential errors which can be returned in a result. I mean, I kinda did understand it, but I need to think for a bit. Wait. Let's see what they want from us. Add the correct return type, result box dynamic. What can we use to describe both errors? Is there a trait which both errors implement? Okay, so we need a return type, which gonna be a result. Okay, so what kind of traits do they have? So this is a pretend user input, and you do a parse on it, and you're trying to convert it to 64 bits integer. And we also try to check if it's a positive non-zero integer. Alright. This is required so that creation error can implement error. Okay. So it's an error trait, right? I mean, we should obviously go and check what parse does. Where it is though? Should be in modules. But weirdly enough, it isn't highlighted for me. Why though? Okay. STD bars. And what it does, it returns this. Okay. So what kind of traits does error have? This is too much. To be honest. I mean, like I'm going to make a guess right now. And it was a wrong one. Okay. Wait. Maybe not. Maybe not. Maybe not. This was correct. But to be honest, I don't really understand like what to read right now. It's like Rust analyzer broken or something. I mean it isn't, but it won't give me any info in this function. Okay, let's read the solution. Maybe it does explain something. Well, it doesn't really explain anything. Okay. I think we could go to bars again. So return this. And F is this. And returns an error. Maybe we should check out the source code. I don't get it. Let's go a bit back. Let's check out this one. Well, this is a trait on song. I think we should like just go and, as they say, they're gonna explain it later down the line. So I'm gonna just believe in that. Okay. This is like really too much for me right now. Right. Using a catch-all error type like box dynamic error isn't recommended for library code where colors might want to make a decision based on the error content instead of printing it out or propagating it further. Here we define a custom error type to make it possible for colors to decide what to do next when our function returns an error. Okay, so from what I understand, like if you're gonna think about language like Python, so this is like the base error class, right? So you can like, which is if I remember correctly, which is exception. So you can catch an exception, but either exception they derive from it. So if you're catching an exception, you catching all the error types, and it's not really good, because if you have a library and you just like returning the base exception, if like some other function, maybe not from your library, has an exception, you can't really differentiate. Like this came from some other function down the line, or was it called by the library itself? Okay. So this is a custom error type that we will be using in positive non-zero integer parse. So what's a partial eq? Let's try it. It's a trait, okay. Trait for comparisons using the equality operator. Okay, so what it means that you can treat this one like an integer, right? Kinda. So this is like what we did before. Positive non-zero integer created, and then there is this parse trait, or is it? Change this return type. Change this to return an appropriate error instead of panicking when parse returns an error. So it panics here. So we're going to do, I think, this or not. Parse position non-zero error from creation. Oh, I see what it does now. So we're going to convert our error, which actually this error, This doesn't work. Why? Though. Oh wait, we should do. Can you do it like this? No. Tap on attention. Okay. But you give it a type annotation though. Parse observes an error. Okay. So we don't need this one. Actually need this one. Boxing errors. A way to write a simple code while preserving the original errors is to box them. Okay. Well. This doesn't really help. This new can return an error, right? Yes. And this can return an error. So why doesn't this one work? Because it returns a result. We can do like this. Ah, okay. Yes, this is exactly what we did. Now we go to the generics. Can be fun. Vector T is generic over the type T. In most cases, the compiler is able to infer T, for example, after pushing a value with a concrete type to the vector. But in this exercise, the compiler needs some help through a type annotation. Okay. What happens? So we have two numbers, n1 and n2. And they have different types. n1 is inside 8 bits integer. And then n2 is an signed 8 bits integer. And we wanna convert them basically into whatever type we need in this vector. Okay, choose T as some integer type that can be created from both of those. Well, it should be then. It should be unsigned. But because it could be more than like this maximum value, it's gonna be 16 bits. Okay. How it's called generics. Okay. Yes, this one is correct. Next one. This powerful wrapper provides the ability to store a positive integer value. We write it using a generic so that it supports wrapping any type. Well, it's gonna be like this, right? But then No? Okay. Well, maybe not like this, maybe more like... Never need that one. Can't find type T in the scope. Wow, it's generic. It's only type. Well, maybe we need to actually read how to do it. Okay. Seems so. This is how it functions. Good. This is how it instructs. Good. But how you write methods of those structs? Oh, okay. Okay. Strength solution. Okay. And now we're doing traits. The trait append bar has only function which appends bar to any object implementing this trait. Has only one function to any object implementing this trait. I see. But it failed. The tests. What? Okay, it should be the capital B. Okay. Implement the trait append bar for a vector of strings. Append bar should push the string bar into the vector. Okay. Maybe not like this, maybe like this. Oh. Not all trait items implement. Okay. First we need to implement it. Alright. Then we take the vector and we push into it. And we push what? We push bar. And then return. So. But then we get an error. Because what? Because this. We still get an error because this should be like this. because we're basically imitating the vector, so the self needs to be mutable in this particular case. And this seemed to be correct. Let's check out the solution. This is important. Sure. This is important. Important. Next one. There are like, what, 5 traits exercises? Add a default implementation for licensing info so that implementers like the 2 structs below can share that default behavior without repeating the function. The default license information should be the string default license. So this is a trait licensed, and it should have some default behavior. Okay. I'm gonna just implement it like this and like this. Okay. But it did fail though. But it failed because I can't type without errors. Okay. I mean, I think I solved it correctly, but just wanted to be sure, you know. What? Need this, right? Right. Looks good. Also, I don't understand because, like, let me explain. In some solutions, they do this. But in other solutions, they do this. Can't they be like more kinda, I don't know how to say it. Forgot the word, to be honest. I think you get what I mean. I hope so, at least. So, to the exercise number 4. Fix the compiler error by only changing the signature of this function. Okay, so we have a trait licensed. And it returns this, basically what we did in the last exercise. And now we need to fix the error by fixing the signature of this function. Well, is it this magic? Okay. Still failed though. Because why? Okay. Okay. But it did work with errors, so why it not working there? Generic data types. Oh, we need to check out the traits readme. And those are the default traits, right? Okay, implemented a trait. Good. But what we need right now is how to call a function with a struct. Base. Okay. Good. I want to see the solution now. Okay. Fix the compiler error by only changing the signature of this function. So we call some function, and we also call other function. We call, so they implement like two traits. Huh. How you do that exactly? Okay. No, need other trait. No. Actually, yeah. No. That's the wrong line. It has nothing to do with traits. We need actually this one, and we need this syntax. Okay. And now we only have to do the quiz number 3. This quiz tests generic traits. An imaginary magical school has a new report card generation system written in Rust. And blazingly fast. Currently, the system only supports creating report cards where the student's grade is represented numerically. However, the school also issues alphabetical grades and needs to be able to print both types of report card. Make the necessary call changes in the struct report card and the implements block to support alphabetical report cards in addition to numerical ones. Right. So we have exactly two to-dos. This one and this one. First one says adjust the struct as described above. Second one says adjust the implements block as described above. Okay, but we also have some tests. And what do the tests tell to us? First of all, turns out you can have grades both represented by strings and by numbers. And this line has an error. So somehow we need to make this take strings or integers. Sorry. Floats. And to be more precise, 32 bits floating point number. Okay? How do we do this? So the quiz tests generics and traits. Well, this has nothing to do with traits. This could be a generic, so this could be something like this. And now, all the errors again. But so it needs to be able to print both types of report cards. Okay. Well, I honestly don't understand how this quiz is hard. Maybe I am the dumb one, to be honest. So the T doesn't implement display. Can I? Okay, so let's check out the generics again. And what do we have about generics? We have this something about bounds. Let's see. So when working with the generics, type parameters often must use traits as bounds to stipulate what functionality type implements. For example, the following example uses the trait display to print, so it requires T to be bound by display. Here. Okay. And I think that's exactly what we need to do. We need this T thingy to do this. Cannot find trait display. Well, that's bad, but we need to. So I think it comes from here. So obviously what we need to do is to do std fmt okay. And this does work, but I now want to see the solution to this quiz. Okay. So we don't exactly need to. Well. I think it's kind of, it could be debatable, so I don't really need to like printable there, yes, but how I can store a grade in something that isn't really printable. I think like the way we did it is okay, but this doesn't have to be like displayable by default, theoretically. Okay, and now we start with lifetimes. But we're gonna do it in the next session, not today. I mean, maybe today, but in the next session, not in this one. So I guess see you next time.